Take care of it immediately now.
Yes.
Yeah. Live on, what is that?
Custom live stream.
What is it? Custom live streaming? What is that?
We are live, Maharaj, now.
On YouTube?
Yes, Maharaj.
Okay.
Yes.
Then here put recording on pause and.
Yes, I will do. Connected, Maharaj.
Okay. Let's put it on pause after it starts. ఈ పిల్లలు ఎవరా పిల్లలు Soumil, that only co-hosts will be unmuted, all others will be muted.
Yes, Maharaj, done that also.
Okay, be very clear about it. Just
Yes.
keep following.
Yes.
Those who are, some children are online, they should not be there. Okay.
Okay.
Children, what are they doing? You ask, with school, why they are sitting, small children. Make announcements. I request all the participants of this seminar, of this webinar today, very special, very important, very focused. Don't keep on shaking your videos, etc. And children need not be there. Okay. This is for professionals and others. Those children whom I am seeing on screen, please avoid. Elders should sit with you. And don't check the monitor, otherwise your videos will be closed, because concentration is very important. Concentration is very important for this subject, and discussion will be there. Question and answers will be there. Children should not. Children should not disturb the proceedings, okay? Whoever it is. Soumil, that is your responsibility to see and mute their videos, etc. Okay?
Yes, Maharaj, done.
Parvita team.
Namaste, Swamiji.
Ready?
Yes, Swamiji, ready.
You have to get co-host now.
Yes, Swamiji, we are joining the meeting.
Quickly, just time up.
Yes, Swamiji, we are joining.
Okay. అది వీడియో యూట్యూబ్ చెక్ చేయమను. Professor Jagdishan, namaste. I'll just start in a couple of minutes.
Sure, Swamiji. Pranam.
Yeah, just waiting for one call. Vasudha? Saumil, you have to make Parvita and team co-hosts. Parvita and team, recitation is there. Screen sharing also is there. So namaste to everybody and very good evening. Shubha Sandhya, Susandhya to all the participants and the respected guest speakers from the Indian Institute of Science, all our good friends under the leadership and support of Professor Jagadishan. So Professor Jagadishan, our old student of the Ramakrishna Mission School, who has been with us for a very long time and participated in a couple of webinars, has joined us along with his colleagues, friends. So I welcome him on behalf of the Ramakrishna Math and Vivekananda Institute of Human Excellence. Today is a very auspicious day, very sacred day, very important day for the youth and the nation. 158th birthday of Swami Vivekananda. From 1985 onwards, Swami Vivekananda's birthday is observed as the National Youth Day to keep up the spirit, the ideals, and the focus on the youth for which he represented and which he stood for, and how this youth in science and technology, in service, in medicine, and any career that they choose, they will work for the welfare of Mother India, welfare of this great nation. That was the vision and mission of Swamiji. So thousands and thousands of programs all over the country going on from today morning, early morning till late evening, and many saptahas going on, 7 days programs going on. And through the VIHE, the Vivekananda Institute of Human Excellence, we have launched a 4-day program today, tomorrow, on the 15th, on the 17th, on various topics concerning Swami Vivekananda's teachings, his contribution, the youth power, science, and sports, and yoga, etc. So for this program, as all of you know, Professor Jagadishan will be moderating, Professor of Department of Aerospace Engineering, IISc Bangalore. We welcome and thanks for accepting our invitation, Professor Deepshika Chakrabarti, and request her to unmute her video. And she is professor from the Department of Microbiology and Cell Biology, IISc Bangalore. Namaste, good evening.
Namaste,
And-
Pranam Swami.
And
Pranam.
welcome to our webinar. Welcome to the Institute of Human Excellence. I welcome Professor E. Arunan, Chairman, Inorganic and Physical Chemistry, Indian Institute of Science, Bangalore. Arunanji, thank you. Welcome and swagatam.
Thank you very much.
To our
It is
webinar.
an honor to be here. Thank you.
And on behalf of the Institute, I welcome Professor Satyam Suvas, who is Chairman, Department of Materials Engineering, IISc Bangalore, another distinguished scientist. And also Professor S. Gopalakrishnan, Department of Aerospace Engineering, IISc Bangalore. All of them, though we have not met, we are good friends as a family of seekers, family of finding out the truth in life, in nature. Indian Institute of Science, one of the best in the world. And not to take much time, we start this program as an offering to Swami Vivekananda with a small song which contains, in essence, a Hindi bhajan, which is a message of Swami Vivekananda composed long back by a great saint, Brahmananda. But Vivekananda liked that song very much, and that is put into music by an accomplished playback singer in Bangalore by name Karthik Raman. He shared his recording to us today as his offering to Vivekananda. Mana chalo, chetan devaki seva karo, janma safal ho jai. That is the Pallavi, that is the first line of the song. Chetan devaki seva karo, janma safal ho jai. Prema pushp se pujan kije, मन दीपक दर ध्यान विचारो घट घट पूर्ण एक निरंजन द्वैत भाव सब दूर निवारो हृदय अंदर मंदिर माही जगमग ज्योत जगे उजियारो चेतन देव की सेवा करो. This is just a 3-minute bhajan. Please listen, enjoy, and be inspired. Yes.
It's not coming up. That's good.
అక్కడ చెక్ చేయి నాకు వస్తుందా లేదా. That was Karthik Raman from Bangalore, accompanied by Purnima and Anirudh Sharma, the top artists who are the young upcoming artists of Bangalore and Hyderabad. We offer our thanks to them, grateful to them for sending this song to us as an offering to Swami Vivekananda. As everybody knows, the roaring call, the divine message which Swami Vivekananda gave from 1893 onwards, that is the Chicago Parliament year, the 400th year of Columbus discovering America, and then four and a half years staying in the United States, spreading the message of Vedanta, message of our culture, of our country, and inspiring them to high levels of divine excellence. And then coming back to India, rousing the whole country towards a new processes, a new understanding of our traditions, and how each one of us at that time, our ancestors, sacrificed themselves for the welfare of the nation, in science, in technology, in social work, in agriculture, so many departments. Everybody in one way or the other was inspired, was guided by Swamiji. So here is our volunteers, our students of the Vivekananda Institute of Human Excellence, young, bright, energetic, intelligent students, 10th standard and above, who are being groomed and trained in the lines of Swami Vivekananda of human excellence. They will recite a few important teachings of Swami Vivekananda on this great occasion as their offering, as their tribute to Swami Vivekananda on his birthday. Over to Parvita and her team.
Our pranams to the Holy Trio. Namaste Swamiji. Namaste to the highly distinguished speakers present in the webinar. Swamiji's message was simple yet powerful and directly conveyed to the youth of India.
He personified the eternal energy of the youth.
It is entirely fitting that January 12th is observed as National Youth Day to rekindle the eternal message of this great son of India.
But what was his message and advice for the youth? Swamiji said, "My faith lies in the younger generation, the modern generation. Out of them come my workers. They will work out the whole problem like lions."
I am born to organize these young men. Nay, hundreds in every city are ready to join me. And I want to send them rolling like irresistible waves over India, bringing comfort, morality, religion, and education to the doors of the meanest and the most downtrodden. And this I will do or die.
Be strong, my young friends. Have faith that you are all my brave lads. Want to do great things. Let not the barks of puppies frighten you. No, not even the thunderbolts of heaven. But stand up and work hard.
Men, these are wanted. Everything else will be ready. But strong, vigorous, believing young men, sincere to the backbone, are wanted. 100 such men, and the world becomes revolutionized.
Work among those young men who can devote their heart and soul to this one duty, the duty of raising the masses of India, awake them, unite them, and inspire them with this spirit of renunciation. It depends wholly on the young people of India.
If you are really my children, you will fear nothing, stop at nothing. You will be like lions. We have to rouse India and the whole world.
Be it in any sphere, Swamiji's quotes are relatable to every attribute of human life. Some of them are education. We want education by which the character is built, strength of mind is increased, intellect is expanded, and by which one can stand on one's own feet.
For character building, Swamiji said, neither money pays, nor name, nor fame, nor learning. It is character that can cleave through adamantine walls of difficulties. Character has to be established through 1,000 stumbles.
In leadership, Swamiji said, One must crush all one's own self under the feet of the community. One must be a servant of servants. There must not be a shade of jealousy or selfishness. Then you are a leader.
In science and religion, what we want are Western science, coupled with Vedanta, Brahmacharya as the guiding motto, and Shraddha and faith in one's own self.
For women empowerment, there is no chance for the welfare of the earth unless the condition of women is improved. It is not possible for a bird to fly on only one wing.
The greatest novelist, Romain Rolland, said, "I cannot touch these sayings of his without receiving a thrill through my body like an electric shock. And what shocks, what transports must have been produced when in burning words they issued from the lips of the hero."
Swami Vivekananda was a prolific writer,
A finest musician,
A great storyteller,
A marvelous poet,
an influential orator,
a social reformer,
and finally, a great source of inspiration to all of us. Therefore, let us all understand Swamiji's quotes and life teachings deeply and implement them in our day-to-day life. Jai Vivekananda.
Thank you very much, Parvita ji and her team. I request our guest speaker, Mrs. Deepshika Chakrabarti, to just give her feelings and blessings to these young students of India.
Namaste.
How did you feel and what is your greetings today?
Yeah, I don't know how to express myself because I am amazed by the way these young minds and these very precious children they have put together about the teachings of the life of Swami Vivekananda. And I congratulate them. I can see that spark in them, and I can really see that that amazing sense of fearlessness, even when they talk and even when they communicate that expression and teachings of Swami Vivekananda.
Yeah.
So I am very humbled, and thank you for making me a part of this show. Thank you very much.
Thank you very much. They'll be very, very happy. They'll be delighted that a professor of IISc.
Oh, you please are welcome to visit our lab and kindly do so, because I will be really honored to have all of you there.
Yeah. Professor Jagadishan, your words of encouragement to our young students. You remember your school days?
It's amazing that anybody who is able to understand and speak out the words of Swami Vivekananda, obviously first he will get transformed and the people who listens will get transformed. And all of you have understood and then came out, and the words actually came from your heart. Wish you all the very best, and try to keep reading Swami Vivekananda's teaching, not just once or twice. Let it be a companion throughout your life. All the very best.
Fantastic. Thank you very much. Professor Arunan, can you just give your greetings to them? They are future scientists or great.
Thank you very much, Swamiji. It's indeed a pleasure and honor to be here. I am very grateful that I could attend a function on the birthday of Swami Vivekananda.
Yes, sir.
We grew up looking at the three pictures you have behind you. It is there in our prayer room, Swami Vivekananda, Ramakrishna and Saratha.
Yes.
My own uncle was a principal of Vivekananda College near Madurai.
Acha,
we were very closely involved with the Ramakrishna at Madurai. So I'm very pleased to be here.
Yeah.
My greetings to all the youths. Indeed, Vivekananda was probably the first to recognize the importance of youth and motivate them.
Yes.
And then, of course, Mahatma Gandhi and recently Abdul Kalam started targeting the youth. Thank you very much for including me in this function. I am very pleased to be here. All the best to all the children.
Professor Gopal Krishnan ji. Can I request Professor Gopal Krishnan to come online and encourage those young students of our institute?
Thank you very much, Swamiji, and thank you, Jagdish, for making me part of this great event. And the way they articulated the teachings of Swami Vivekananda with such an energy and enthusiasm is really amazing. I hope that whatever they said today is very relevant even in the current setup and how important the teachings of Vivekananda are. I wish all the very best to all the youths who have made this possible. I thank you for giving me an opportunity to be part of it. The teachings of Vivekananda is very relevant. What is happening today in the pandemic days, and this is the teachings that gives us peace and happiness in these days, especially in these troubled days. And I really thank you once again. I thank all the students for articulating the teachings with such an energy, which is really amazing.
Yes, very important. Professor Satyam Suvas, we request you to just share a few thoughts.
Namaste, Swamiji, and my very best wishes to the students of the school who have presented this very nice thoughts in a very effective way. I think from the body language and the way the sound was coming out, it clearly reflected that they have imbibed the teachings of Swami Vivekananda. And I'm quite sure that with these children around and who will be the future of our nation, the future of our nation is very bright. So
yeah,
once again, I express my very best wishes. And I always say that please continue reading the texts, which there is ample texts published by Vivekananda Society, Ramakrishna Mission. And all these things we keep reading, and whenever reading is the basic thing that you can do at this point, and that can really transform you, and then by virtue of that you can transform the rest of the world.
Yeah.
Thank you.
Thank you very much. So the Parvita, thank you. All the best. Siri Chandana, Neeraj, and then Neha. All these
Thank
four.
you very much, Swamiji.
And collecting all that suitable to the occasion, and keep up that spirit and march on towards victory and towards glory. Hope to see you all more again and again in these webinars. Okay. Now you can participate, you can listen, note down what these outstanding scientists, professors who have a lot of experience, a lot of richness in them, how you can participate in nation building through science and through your life. That is also very, very important to add to what Swamiji said. Okay. Thank you very much. Wish you all the best, and greetings for Sankranti and greetings for Vivekananda's birthday.
Thank you, Swamiji.
So while welcoming all the 5 panelists today, Professor Jagadishan, Satyam Suvas, Deepshika Chakrabarti, Professor Arunan, and Professor Gopalakrishnan, this is the time for us to recast our thought process, search for truth, search for the reality in life, and make a great living. Vivekananda's letter from America to the Maharaja of Mysore said, "My prince, they alone live who live for others. The rest are more dead than alive." And later, how he influenced, how he inspired the great people to sacrifice their life for the welfare of this nation. At the spiritual level, at the social level, at the academic level, and maybe sport, and maybe any sphere that I am looking at today, Swamiji has given his blessings, and whole nation is to be rejuvenated, or it has to be a resurgent India, awaking from her sleep. And last 9 months, pandemic time, things were not very good, but still life has to go on. Life has been going on, and we are into the 21st year, in the 21st century. So the real purpose of education is to manifest the perfection which is already in man. Education is the manifestation of the perfection already in man. There is external nature which has got its own perfection, its own manifestation. There is an inner nature which has got its own perfection, its own difficulties, its own divine nature. So by a symbiosis, by an understanding between the external and internal, how we can evolve in life, that is real science, vidya, search for truth, jignasa, that pipasa, the thirst for knowledge, which the students need to have, the youth need to have. And these 5 scientists, Professor Jagdishan and his team, who have readily agreed to our invitation to participate in this webinar on science and nation building. And later, you are welcome to interact with them after their short presentations. So not to waste much time today, because science is such a vast subject, it's an ocean. We are not going into the academics, but the spirit of science and how that spirit of science, the spirit of search and spirit of knowledge can be used, can be utilized for our nation, for our life. So academic side, your college, school, university, and IITs and IISCs are there. That details we can go later. But now we are looking at a different paradigm, how Swami Vivekananda brought about this metamorphosis. And this birthday, the National Youth Day, will be a memorable one to all of you for meeting the 5 outstanding scientists, the world-renowned scientists in their own fields. And I'm not going to introduce them because I request Professor Jagdish Gopalan, who is part of our family of the Ramakrishna Math, who studied in Mysore school. He will take over and he will introduce, and then all the 4 scientists will speak before you. Then we come to the interaction session, the Q&A session, and then we have some observations, and we'll conclude by 8 o'clock or sometime. So thank you very much again, welcoming everybody. And I will also learn a lot today about research, about science, nation building, and see how the youth and our volunteer team and the whole nation is watching. Nearly 300 people are online today. Many are watching on YouTube, and many are on Zoom. Professors are there, college students are there. And over to Professor Jagdish Gopalan, Professor of Aerodynamics, Indian Institute of Science. Welcome, Professor.
Thank you, Swamiji. Lovely good evening to all of you. At the outset, I would like to wish all of you a very happy new year and greetings on the occasion of National Youth Day. What we will do today is that I will just introduce this topic of science and nation building briefly, and then all the 4 eminent, internationally renowned scientists will give their views for about 10 to 15 minutes, following which we can have interactions. I'll just share my screen, and then probably we will be in a position to move forward. Are you able to hear and see my screen?
Yes, yes.
Okay. So today is also a little bit of personal sadness on one level, but then happiness on the other level. Before we actually begin, I would like to offer my humble salutations and homage to Swami Harshanandaji Maharaj, who left for the heavenly abode this afternoon. Swami Harshanandaji Maharaj was the president of the Ramakrishna Ashram in Bangalore. And what is very apt for this occasion is Maharaj was the principal of the Ramakrishna Institute of Moral and Spiritual Science when we were there as students in Ramakrishna Vidyashala. And one story that he told me when we were just about to take 10th examination and also 7th standard examination probably rings a bell in me even after 42 years. And he was telling as young students, whenever you feel you get into examination, you always feel that tension. So he used to say that if there was a engine train, which was going up the hill in, say, in Ooty, and when the engine had to go up the hill, it found it very, very difficult. Just as all of us would feel the tension before we enter the examination hall. It appears the engine started telling itself, I think I can, I think I can, I think I can, I think I can, I think I can. And before it realized, it was already up the hill. And then it was just going down. And then the engine started saying, I thought I could, I thought I could, I thought I could. That's what he used to say, that before you enter the examination hall, please keep saying, I think I can, I think I can. And after the exam is over, you can always say, I thought I could, I thought I could. I think this story has remained with me for a long time, and he was one of the outstanding monks of the Ramakrishna order. So I thought this is a good occasion and also very special that probably the God Almighty took him on the birthday of Swami Vivekananda, which is again very special. The topic of today's lecture itself, the panel discussion itself is very interesting. We are talking about nation building and science. Obviously, many of us would like definitions to be there. So I just would like to show you a few things before I pass it on to my colleagues. What do you define science as? Probably to me, understanding nature in totality, probably using logical and systematic methodology. And based on irrefutable evidence is probably science. And science is a way of life. So it is not just physics, chemistry, mathematics, or biology. There is science in everything that we do on the earth. And it is not an overstatement if you say that science is also a way for salvation. In fact, the autobiography of Bharat Ratna C.N.R. Rao is titled like that. Science is a means of salvation. But if you consider India, India is a very special place. I just stumbled upon this photograph that you see here, which was built in the 18th century library, where all the four things are there. There is a mosque, there is a church, there is a temple, there is a Gurudwara in one of the minarets of a public library. And this, in some sense, to me, represents India. India is one of the very unique places around the world where peaceful coexistence has been something unbelievable. Even the people from the early centuries, starting from our kings, Cholas to Mauryas, all of them, they actually had equinominence and then they took care of everybody in the society. So our nation, India especially, embodies on this. So how do we strengthen using science and then build this nation? But all of us are bombarded upon when we say science. There is basic science, there is engineering, there is technology. So we really don't know what one to study. To me, basic science appears like Brahma. If I were to, borrow something from Indian mythology, basic science creates new information. Basic science creates new knowledge, and it makes you wiser. Unless there is basic science and unless we strengthen that, there is no way we can build upon any engineering or technology. While basic science is like Brahma, engineering is like Vishnu. It has several avatars. In fact, not just 10, maybe much more than that. Then technology is something like Shiva, because the moment it is born, it is destroyed. And new technology again leads to new findings, new science. So it's very important. Science is the foundation on which you don't see that outside. The superstructure is engineering, and technology is the enabler which makes it happen. This century particularly has been a century of disruption. There are several technologies which are born. Probably your generation will see so much of change, and starting from the first person who struck 2 stones and created a spark, who was the earliest scientist the earth had, till date, science has actually played a major role, starting from Industrial Revolution 1, 2, and today we are in Industrial Revolution number 4. On this occasion, I would also like to just remember a few scientists who actually changed the entire way we do things. And these are, again, of course, these are all debatable. There are several scientists, but I thought on this occasion, you should remember these people. Marie Curie, to me, was one of the most amazing people who ever lived on this earth. Not just she won 2 Nobel Prizes, that is not the issue, but she took all the patents in the name of humanity. She is probably one of the few who has done that. And even today, the Marie Curie Foundation gets millions of dollars from the royalty of her patents. Even today in Paris, if you go, you are not allowed to stand in her grave for more than 20 seconds because there are a lot of radiation which comes out. When she found out about radiation, little did she know that it would continue to cure people out of cancer even after 100 years. And she is a perfect example of how science should lead to, ultimately should lead to service to humanity. And once you have service to humanity as the foundation of any science, nation building becomes routine. In fact, this man was also very amazing, namely Michael Faraday. In fact, when he found out the basic scientific knowledge, The very history itself is very interesting, that he had put a very small experiment where magnetic lines of force, he was demonstrating that. He had a magnetic line, 2 magnets, and whenever there, lines of force are cut, then the EMF is generated. One of the British noble who was walking, he asked him, what is the use of this? Then he said, sir, please watch out. You will probably charge people who will make use of my idea, not now, but for several centuries to come. I'm sure all of you will agree, even today we are paying electricity bill. That's the power of science. And our own person who gave immense self-pride to science in India, Sir C.V. Raman. Of course, all of these people have made life what it is. And what we will do today is to really look at how things are going to change. My own personal guess is in the next 50, 60 years, people will start living longer. Maybe you will live for 150 years. Future wars are going to be in space, not on Earth. You may have an artificial brain to supplement human brain. You may have genetically manufactured life on this Earth. You could also have space colonies, mineral mining. I just put few things that I thought is going to be very important. How do you really adopt yourself when the university education is going to be only maybe valid for about, say, few, not even probably couple of years after you come out of college? So in this context, how do you define science, number one? How do you adopt technologies and move forward in an era of disruption? And how do you contribute to nation building by way of science? These are the broad parameters around which this panel discussion will begin. And without much ado, I would start off. And I think many of you as students always read about definitions. Define X, define Y. But today we are so lucky to have amidst us the person who has redefined hydrogen bond, not in India, but in the entire world, Professor Arunan. In fact, he headed the International Union of Physical and Applied Chemists Association nominated committee, which went into redefining hydrogen bond. And that is the definition all of you will read, not now, for several years to come until some new information comes on board. Professor Arunan is one of the world's leading scientists in the area of hydrogen bond and then microwave spectroscopy. He's a very special scientist that he ended up building his own microwave spectrometer in IASC. And we are lucky to be collaborators for several years. And he is there with us, and he's also fellow of all the leading academies. And Arunan, thank you very much for joining us today. And I would request you to address the audience. Professor Arunan, please.
Thank you very much, Swami, as well as Professor Jagadish. Let me share my screen. I will try to keep it to 10-15 minutes, as Professor Jagadish pointed out. I should go to the home screen. I'm going to just spend some 15 minutes talking about diverse topics. This is based on a recent talk I gave, making weak bonds, breaking strong bonds, and defining all bonds. Experiments with supersonic waves. One thing I'm very pleased to tell all of you is that every experiment we have done is based on equipments we built here. I'll mention this briefly. As Professor Jagadish already pointed out, understanding nature is science for me in very simple word. And of course, searching for truth is spirituality. Swami had written to me, inviting me to participate in this section. So I thought I will show you some important documents, original documents. J.N. Tata, who thought about building this institution, wrote to Swami Vivekananda on 23rd November 1898. He said, I trust you remember me as a fellow traveler on your voyage from Japan to Chicago. This is when he gave the famous talk. I very much recall at this moment your views on the growth of ascetic spirit in India and the duty not of destroying, but of diverting it to useful channels. I recall these ideas in connection with my scheme of research and stuff science for India, of which you have doubtless heard or read. It seems to me that no better use can be made of the ascetic spirit than the establishment of monasteries or residence halls for men. Of course, that's what they say in the old days, dominated by the spirit, where they should live and with ordinary decency and devote their lives to the cultivation of sciences, natural and humanistic. And then he says, I am of the opinion that if such a crusade in favor of an asceticism of this kind were undertaken by a competent leader, it would greatly help asceticism, science, and the good name of our common country. And I know not who would make a more fitting general of such a campaign than Vivekananda. This is a letter Tata wrote to him. It wasn't clear if Vivekananda had responded to this letter at all. Nothing could be found. But Swami Vivekananda was running an English magazine called Prabuddha Bharata. An editorial was published in this journal in April 1899. I hope you can see. This Swami Vivekananda seems like an addition later on. It doesn't fit with the other things. As science, you look at everything and ask questions. But this is what the editorial says. We are not aware if any project once so opportune and once far-reaching in its beneficial effects was ever mooted in India as that of the postgraduate research university of Mr. Tata. The scheme grasps the vital point of weakness in our national well-being with a clearness of vision and the tightness of grip, the masterliness of which is only equal by the munificence of the gift with which it's issued to the public. I will share this talk with others. You can read. The editorial ends. We repeat, no idea more potent for good for the whole nation has seen the light of the day in modern India. Let the whole nation, therefore, forgetful of class and interest, join in making it a success. And I am glad it's become a success today. I'm going to spend the next 10 minutes roughly talking about a few things. I mentioned making weak bonds and defining all bonds. Professor Jagadish did point out about the definition of hydrogen bond. Also talk about breaking strong bonds. In my career in IISc, we built a microwave spectrometer in the inorganic and physical chemistry department. I also had a strong collaboration with Professor Jagadish and Professor KPJ Reddy, who is retired now, in building shock tubes. In fact, somewhat coincidentally, the microwave spectrometer has been used to study fundamental science, and the shock tubes have been used to study both fundamental science as well as very applied research. We can talk about ignition delays of jet fuels, drag reduction of rockets and missiles, and formation of early molecules, astronomy and astrophysics. If you think about bonding within a molecule, I am sure all the students have studied chemistry. They know about covalent and ionic bond. But bonding in a molecule has always been a confusion, even for chemists. Coulson, a famous author, says, sometimes it seems to me that the bond between two atoms has become so real, so tangible, so friendly, I can almost see it. Then I awake with a little shock. This is a shock one have, not the shock tubes I'm talking about. This is for a chemical bond, is not a real thing. It does not exist. No one has ever seen one. Up to this point, I might agree with Coulson at that time, but he also said no one can ever. It's a figment of our own imagination. Of course, Coulson could not have predicted what is possible, but what's really interesting is this thought parallels what Van der Waals, I'm sure all of you know who Van der Waals is. His equation of gases is studied in all schools. Van der Waals said the same thing about molecules. He says it will be perfectly clear that in all my studies, I was quite convinced about the real existence of the molecule. I never regarded them as a fragment of imagination. Imagination is, of course, very important. Kaufman had this, he said, defining is difficult, just have fun with the richness of this idea. And they had said chemical bonds are made of electrons, and that is something we can see now. You look at this figure, this is pentacene. I hope some of you have learned chemistry. All of you know benzene, naphthalene, anthracene. You keep drawing benzene rings. Now we can image the electrons and we can really see the bonds. This is about the bonds within the molecule. If we talk about bonds between the molecule, that is difficult. Intermolecular interactions or intermolecular bonds have been a difficult thing to understand as of 2020, 2021. It all started with the Van der Waals equation. Ideal gas law assumed that there is no interaction between molecules and the molecules do not occupy any space. And this A and B constants were introduced by Van der Waals to take care of attraction between the molecules, denoted by A, and the volume of the molecules in the container denoted by the B. So they do contain some volume, they do occupy some volume. Based on this equation, van der Waals forces, van der Waals radius, van der Waals volume, van der Waals interaction were all used. So all intermolecular interactions were called this way until Linus Pauling discovered water had this structure based on crystallography, and hydrogen sulfide looks like this. If you look at water, each water molecule surrounded by only 4. This is somewhat very loosely packed. As you all know, when the water melts, we have liquid water, ice melt, but the liquid water is more dense than the solid water, so the ice floats in water. Now, if you ever thought about it, any solid does not float in liquid, but ice floats in water. That's because ice is less dense because it's connected with only 4 molecules. Hydrogen sulfide looks like on the right. It's a close packing of spheres. Each H2S is surrounded by 12. If you look at 1 molecule of water and 1 molecule of hydrogen sulfide, they look exactly the same. But when they combine, they look very, very different as apples and oranges. So Pauling said this is hydrogen bonded and this is van der Waals interaction, even though nobody really knew what was hydrogen bonding and what was van der Waals interaction in the early part of 20th century. If we think about attractive and repulsive interaction in humans, we think we understand humans better than the molecules. Here are 2 men shaking hands and smiling. You can say they are attracted and there is bonding. Here again, you see 2 men hitting each other hard. There is plenty of contact, but there is clearly no bonding. We might call it anti-bonding. Here you see a train, maybe in Uttar Pradesh or Bombay. There are a lot of contacts, but there's probably no attraction or repulsion. Isn't this what we call as close packing? Atoms are touching each other, but we don't know if they are bonded or they are anti-bonded. And of course, you can also have situations like this. You see on the left, person smiling at each other without any contact, and you can say maybe they are bonded. On the right, you see 2 men with too much contact, and clearly you can't think of any bond. One person says, probably I want to bond. Other person says, I don't want to. What is a hydrogen bond? The precise definition was elusive in the 90s when I joined IPC department. These were 3 books that were published that year, 97, 99. And all of them said it cannot be defined. And they would give structurally the distance between X and Y should be less than van der Waals radii. This would be linear. These are things we can measure with microspectroscopy. We built a microspectrometer and we wanted to look at water dimer and H2S dimer. Water dimer, there has been plenty of results. The structure looks like this. If you remember the ice structure, it looks exactly 2 water molecules from that. But H2S dimer looked like this according to theory, but there were no experimental results available at all. We built the microspectrometer. We wanted to study this. Before we studied, there were very few reports on this. They looked at the microspectrum and concluded that the structure would look exactly like this, like 2 spheres. And this doesn't tell us much, but you cannot see a microspectrum unless there's a dipole moment in the structure. So the possibility is that the 2 H2S molecules are like this and they are rotating like this so that we could see the microspectrum. But this also doesn't give us any information about the structure. In order to get this information, we needed to collect rotational lines when K is not 0. I cannot explain to you what this is, but basically to get the structure, we needed a lot more lines and we measured. This is my student Arijit Das who measured this. And we showed the structure is exactly like this. We showed both water and H2S can now form hydrogen bond. And of course, this was covered all over the world from American Chemical Society, Royal Society of Chemistry. Once we showed that H2S can also form hydrogen bond, IUPAC had to redefine hydrogen bond. I wrote to them saying that we should define it again. And when I wrote to them, I didn't expect me to ask me to do it. They said, I can do it. I should form a task force of scientists from all over the world, not my friends and collaborators. So I formed this task group and we came up with definition, which is accepted by IUPAC almost after 2 years of reviewing and 25, 30 people reviewing it. Basically, we said the XH in which X is more electronegative than hydrogen. If it interacts with another group of atoms or molecules, then there is an evidence we have a hydrogen bond. This was important because we can have structures like this in which hydrogen is closer to chlorine, but chlorine is bonding to the carbon. Now these are called halogen bonds. because I don't want to continue talking about this. If anyone is interested, I can talk about this for hours, but let me move on to shock tubes. It's time to warm up. We built many shock tubes to heat the molecules to very high temperature and then break them apart. Why did we do it? Because I am sure, like Van der Waals, all of you know about Arrhenius. Arrhenius equation shows this. Molecules don't react arbitrarily. They have to be energized. And there is an activation energy and there is a pre-exponential factor. And you need this to explain the reactions. Of course, A is pre-exponential factor and D is activation energy. There is a transient state theory in chemistry which can explain this empirical equation of Arrhenius, and that is given by this potential energy curve. The molecules are in a well at very low temperature. They have to cross this barrier at the transient state. They have to climb up and move up. That needs energy. This can be done by thermal heating. It can be done by bringing two methyl and chloroethyl radicals together from chemical activation. We can use a light to activate. All of them could be explained by this. But what happened was between ethyl chloride and dichloroethane, there was a difference and the experimental results could not be explained. A shock tube could help. That's what I had thought. So I wanted to build a shock tube after joining IISc, because I will show you a table. I don't expect any of you to read and understand this. You look at this table, there is numbers. This could be stock market. But you see this column, particularly this row, looks very different, which I have circled in red. All the others have numbers like 13, 14, and 200. This is less. You can plot this. Sometime in papers, you see tables and plots. When you plot this, that is the point that fills exactly in the line. In order to resolve this, we need to build a shock tube. I had a student who is right now a faculty in IIT Madras and a collaborator, Professor Reddy. We built the shock tube. It can heat the molecules without the shock tube being heated. You can put a furnace and heat the molecules, but in furnace, wall gets heated and then the molecules. In shock tube, wall remains at room temperature and the molecules get heated. We build the shock tube. I won't give you the details. We basically produce a high temperature pulse, and then we could do the reactions. We could do the HCl elimination and now get the rate constants, which look exactly like this, and also resolve this. So we built the shock tube for doing this, but once you have the shock tube, we can do many other things. Then ISRO and DRDO contacted us, asked if we could measure ignition delays. In order to do ignition delays, this graph basically explains why the two different numbers agreed very well. That's a mathematical anomaly. We could also measure ignition delay with the shock tubes. We had to make some small changes, and now we can measure ignition delay. Basically, whenever an ignition happens, a CH radical is produced and that emits light, which we can detect. And the pressure rises suddenly, which we can also measure. And this time here between these two is the ignition delay. We could measure this. JP-10 was a rocket fuel that was being used by DRDO. Harish Chakravarti was a student here. We measured the ignition delay. It's a similar experiment like the fundamental experiments I was telling you. We showed that if we order triethylamine, we can reduce the activation energy significantly. And what was surprising to us that this was covered by people all over the world, like Pakistan, America, everywhere they were covering these results. We had also shown that if we coat chromium on the missile top, we can reduce the drag, and DRDO has promised to test this. Now we built the shock tubes to do some fundamental studies. We can measure ignition delay, we can measure the drag of a rocket, and we can also look at fundamental studies. How did life begin in Earth? How did the atoms become molecules? We're studying the carbon and hydrogen reactions, and this work shows interstellar dust analogs can be investigated with the shock tube. This was done in collaboration with the French group. Now the French group comes here to make measurements. We will always hear about Indians going abroad to make measurements. We have built facilities. Now they come here to make the measurements. I will stop here now. We have used a home-built pulse nozzle Fourier transform spectrometer, and we could define hydrogen bond sharing a task group formed by IUPAC. We built the single pulse shock tubes in collaboration with aerospace engineering. Now scientists from all over the world come here to study both fundamental like astrophysics as well as applied like rocket propulsion. I would like to thank you all for listening. I'll be happy to answer any questions you have now or later. Thank you all.
Thanks, Arunan. So we will take the questions at the end. And I think, friends, you would have realized scientists are so fond of looking at fundamental things which has got a far-reaching application. So starting with the basic science, how it has been used in some of the current missile programs, as well as in rocket fuel, was very nicely elucidated by Professor Aruna. We also have amidst us today Professor Deepshika Chakravarti, who's a very unusual scientist in several things. Not only she looks at fundamental biology of salmonella, but she is also someone who has actually found vaccine for typhoid. And in her own laboratory in the Indian Institute of Science, she is involved in understanding the infectious diseases from a very, very special angle. And now several of those findings are resulting in a lot of final application. Friends, you should also remember, as the basic science advances, people would actually convert that science into something very useful. And because that is useful, people will start using it. And then the nation building is automatically part of the journey. I'm very happy to have Professor Deepshika Chakravarti today, who is one of the world-renowned specialists on infectious diseases. We have been collaborating on several programs on using shockwaves for various applications, which would actually be solving the miseries of people in the years to come. She's also the fellow of all the leading science academies in the world. She was a Humboldt fellow. And thank you very much, Professor Deepshika, for joining us today. Welcome. And then I would request you to address the audience. Professor Deepshika.
Thank you. Namaste and pranam to all. I would like to thank Professor Jagdish, my very, very close colleague, and Swami Vivekananda. Thank you very much for giving me this opportunity. Now, I thought that I would try to do something a bit different, and I would like to share my slide. We will definitely try to understand. I hope that you can all see my slide.
Yeah. Yes.
Okay, thank you so much. Yeah. As Jagdish mentioned, that we had been a very long-lasting collaborator, and you will not believe that how this all started. It started just over a cup of tea when we both were having one meeting in the student council meeting. He is an aeronautic engineer, aerospace engineer, and I am a biologist, a microbiologist. And you can imagine that how this culmination took place and which led to something very wonderful. So Professor Jagdish and his lab and my lab, we are extremely, extremely strong collaborators. So today what I'm going to do is, I thought that because you are a very elite audience, and I'm not very sure why my slides are becoming...
Deepshika ji, just a small note where you can just go there and say, disable the this one in your...
It is done. I think it is done now, Swamiji.
Yeah, there will be some children or somebody.
Children. Okay. Oh, what should I say? I should say disable.
That point is there. I'll just check. In your share your this one.
Yeah.
Only you can do that. Saumil, please guide.
Yes, ma'am. You need to go to the options, and there annotations, disable annotations mark will be there.
Options.
View options near the screen sharing itself. There are view options.
Near the screen sharing. Shall I click or on more? What shall I do on the more?
Yes, click on more and disable annotations.
Click on more and disable participants annotations. Okay. Yes. Thank you so much. Yeah. I learned a new thing today. Every day is a new lesson for me. Now, as Swami Vivekananda ji have given us a title about science in nation building. So I wanted to discuss with you, as I mentioned to you, that you are, it's a very elite audience. You are actually learning in the school of Swami Vivekananda's teaching. And we do have Professor Jagdish with us, who is from the same lineage. And it's very different to see the way by which they actually interact with people. And I was very fortunate to interact with Professor Jagdish, and I actually found him very different. So science in nation building, how and why? I would like to open up this topic and then finally discuss with all of you. as per the definition of what is science. Now, it defines as the intellectual and practical activity encompassing the systemic study of structure and behavior of the physical and natural world through observation and experiment. The word science, it arose from a Latin word, it's an old Latin word, sire, then scientia, and then New English word that is science, which essentially means a knowledge, a knowing, expertness, or an experience. So this is science. Now, what is nation building? Nation building, as by definition, is a constructing or structuring a national identity using the power of the state. Now, according to the Columbia University sociologist Andreas Wimmer, the three factors which tend to determine the success of nation building over the long run is the early development of the civil society organizations, the rise of a state capable of providing public goods evenly across the territory, a very important point, providing public goods evenly across the territory, and the emergence of a shared medium of communication, a medium of communication which is extremely powerful so that it can be shared across. Now, if you really look into the Constitution of India, it encourages the citizens of India to have a sense of scientific temper, which is according to the fundamental duties under Article 51A. It shall be the duty of every citizen of India to develop scientific temper, humanism, and the spirit of inquiry and reform. So this is how strong the science is, also mentioned in our Constitution. So who can be better than in today's talk to pay all our gratitude and homage to one of the unmatched nation builder, Swami Vivekananda. Among the other national reformers, Swamiji stands far, far unmatched. So that is how I always looked at him as an unmatched nation builder, because his words are simply unmatched. He's the one who emerged as an icon of youth and young India. He emphasized on technical education in one side and learning Sanskrit on the other side. Swamiji mentioned, India alone has the potentiality to bring about the synthesis of the East and the West, that is the spirituality and the material progress. Now, these two are very important words, spirituality and material progress, was bestowed by Swamiji to maybe happening in India alone. So he really had that kind of a vision for India. And education alone. That was the power of education and the science that he brought in. And one of the most important point that he mentioned, that the country, that nation which does not respect women can never become great. So this unmatched nation builder, Swami Vivekananda's teaching actually has kept us alive. As a scientist, it has kept us alive. Now, the very fact that I am sitting here in the IASC is because of Swamiji. It was a dialogue between Swamiji and J.N. Tata over their voyage in the summer of 1893. It is one of the very, very famous incident upon the genesis of Indian Institute of Science. Now, how a small dialogue over a cup of coffee or over a stroll or over a voyage can actually change people's thinking and people's vision. And it was just this dialogue between Swamiji and J.N. Tata, where Swamiji impressed upon J.N. Tata and mentioned there is a need to transition to manufacturing than merely taking away easy way of trading raw materials or semi-finished good. And he also impressed upon J.N. Tata, saying that this would help create jobs, add much greater value to the product sold, and then take country ahead of the road to self-sufficiency and development. Now, here is the word technology, I will bring it in. Now, training the Indians, not just in science, because that is a seek for the truth and the knowledge, but also technology, which is a resultant of science, so that the country's requirement could be significantly fulfilled by the domestic manufacturing, which actually after these many years, we are talking about the Made in India concept. Everything was laid down by Swami Vivekananda. If anybody who follows the teaching of Swami Vivekananda is actually a very true nation builder. I have nothing much to say more than that. And IISc took birth in 1909. Neither J.N. Tata could see the building coming up, And J.N. Tata died exactly 2 years after Swami Vivekananda ji died. So at a very young age, the kind of mark that he made and the IISc is a resultant of this magnificent talk that happened over a voyage. Is India new to science? Of course not. India introduced zero to the world, Aryabhatta, wireless telecommunication by J.C. Bose, S.N. Bose, you name it, Ramanujam, C.V. Raman, Homi Jahangir Baba, almost, and Abdul Kalam, who also shared his power of youth and saw the youth as an icon. Now, India is not new to science. Then in that way, how is that entire thing helping in the nation building, which such a strong consortium of the scientists who have introduced a novel so-called interpretations, the formulas to the world, where is it now? Like Aryabhatta introduced zero, can we understand the value and the power of zero? With 137 crores, 28 states, 22 languages, 19,500 dialects, largest producer of milk pulses, second largest producer of rice vegetable, high GDP after US and China with 2.72 lakh crore, we are only spending 0.7% of the GDP in science and technology. And when this very important topic of science in nation building came up, and Swamiji has actually given us the topic to discuss, because you are all very young minds and you are the niche and you are the nuclei who is going to build this up, it's very important for us to understand that the 0.7% of the GDP in science and technology, is it good enough to use the science as a nation building? And the answer is actually no, it has to be spent more. But more than that, how this thinking process goes. Now, nation building is standing on these very, very strong pillars of science. Without science, there is no nation building. And science, which leads to the technology, and the technology leading to the development. Science directly or indirectly can lead to the development. But the question is that what do you understand, or what do we understand the meaning of development? It is very different for different people. Science and nation building has to be bridged with a very, very important component, that is character building. Now, science has a very two important aspect, or a bifurcation. One is a social science and another is a natural science. Now, the importance of the social science in the character building and the nation building is one of the strong foothold that if we inculcate in us, then I am very, very sure that we exactly understand the so-called spiritual or the holistic meaning of doing true science, and thereby contributing to the nation building. Now, character building is something which I am very sure that I don't have to tell you all, as a disciple of Swami Vivekananda ji and all my young precious children who are actually following the teachings of Swami Vivekananda ji. You are all much, much more luckier than me, where I did not get much chance, though I have a history. My own maternal grandfather actually became a monk and became Swami Chinmayananda, who was in the Belur Mutt for a very long time. Now I really recall all those moments, but it is something about the character building. Now the science will lead to the technology, can lead to the individual building, and the individual building, each one of us, individual building will lead to the nation building. It's like a brick. So science is the anchoring part. It's acting like a brick. But the question is how and why. It is such a vast topic. It is such a vast description of the entire concept of the science. It's like a brick. We have a brick, and the brick is slowly making it up, and it will take us to a stage where we indeed have this so-called finished product. But there is an extremely fine balance between the building and something to demolish. Now that entire character building, which can take us to a very productive phase of seeing something really good finished product, can also, if not built properly, the character not built properly, can get to this kind of a demolition. So it is a very, very fine balance where the character building, which is inbuilt in these teachings, and the fearlessness that is inbuilt in this teaching is coming up in a very big way for real nation building. So who are these nation builders? Are they only the policymakers? No. Is GDP the main indicator for the nation building? Answer is absolutely no. If I would tell you this, then Bhutan, who is very lowest in the GDP, is actually one of the most forward country or the state where the people are so happy, and it is the only state or the only indicator or the only state or the only country which have the Ministry of Happiness. Have you ever heard any country which have a real Ministry of Happiness and their happiness quotient is far, far more? So for them, GDP is nothing. For them, having a mobile connection is absolutely nothing, or getting or any kind of high technology is nothing for them. The nation building indicator is something much, much different. So indeed, it is not. Is technology alone the main criteria for nation building? The answer is partially yes, because technology results from science. Now, is science the sole criteria for nation building? And the answer is yes. This is the sole and actually the whole criteria, because science joins the character and it joins the nation together. So if it begins in a very proper way with a very proper teaching, there is no doubt that it is going to be an amazing nation building capacity that each one of you will possess. But there are challenges for nation builders. All of you in Ramakrishna Mission, as well as in the Vivekananda Society, are in fact nation builders. But you all have challenges. And what are the challenges? Now you are very young children and you are all an isolated, you will be a nuclei to propagate this. Providing public good to all, providing education to all, providing shelter to all, and providing healthcare to all. These are all the challenges that are going to come to you because you are nation builders. Having said that, let me come to one very interesting rule, what I call it as a Pareto's 80-20 rule and nation building. Now, Vilfredo Pareto, he was an Italian economist who in 1906 made a scientific observation that evolved into Pareto's rule or 80-20 rule. What this rule states is that 20% of the process input drives 80% of the output. And this is known as the identification of the vital few. You need a mass to do something, but actually you need just a vital few to form that nuclei and then make this massive change. The question for all the nation builders, can you identify 20% of the people that will drive 80% of your nation building? So is we have the ability to have these 20% of the people identified so that the 80% of the nation now can be built? It is within you. So I am very sure that for you, this will not be a very difficult problem. And the three things which must come is to stop, analyze, and prioritize. If all these 3 points we do it, then I am very sure that Pareto's 80-20 rule and Wimmer's 3 very important concept of providing public good, a shared medium of communication, is really going to be very much fruitful and applicable when we talk about the so-called nation building. Who can be the nation builders? The vital fews who have eagerness, who are extremely vibrant, just like Swamiji had. Even looking at Swamiji's picture, you feel that light in you, you feel that aura, and you feel that energy which will make you up, and it will just kick you off from your seat and do things which you would have never thought of. Asking questions, it is the inquisitiveness at every single point, that the questions that you are asking, the curiosity, more and more curiosity, the persistent nature and the sustenance, and of course, learning in depth. So all these characteristics, if somebody inculcate and they have it, they are the vital fews who will be very important for the nation buildings. So very quickly, I'm going to tell you about a little bit of my own science, which is very interesting because we learn a lot of things from the small, invisible, tiny bacteria or a microbe. Now, all you children, you are welcome to IISc, and I would be very, very happy to welcome you in my lab. Having said that, let me tell you that 80% of our student, integrated PhD student, which I am a coordinator, are from Ramakrishna Mutt. And we have that amazing number of students now from Ramakrishna Mission who are a part of our integrated PhD student. So if you see here, I've put a small title, Life in a Vacuole. What does it mean? Of course, today in COVID time, today we are in a kind of a vacuole, but I'm talking about my bacteria. Now I work, as Professor Jagdish mentioned, I work with a very important bacteria which causes typhoid fever, that is Salmonella. Now, Salmonella has a mind of its own. It is invisible. It is just 1 micron in length and 0.8 micron in width. And it has a mind of its own.
It gets into the cell type. You don't have to worry about the technical terms. But you see the green are the salmonella and these red ones are some cellular organelles. Now, these tiny bacteria, they have a mind of their own. They get inside the cell and they reside in the so-called vacuoles. That is their home. That is their niche. They are not going to quit their vacuoles and come out. They are going to stay there. They are going to harness all the power of the cell and make it somehow utilized for their own purpose. And they are very, very successful in doing that. So this life in a vacuole is very important for them. They can do it in many different cell types, say in the macrophages or in the intestinal epithelial cells. They always live in a single bacterium in a vacuole. That means if you have this one vacuole, there is only one bacteria. And like this, there are multiple. What lesson it teaches us? I am a microbiologist by training, but I could never ever, be less fascinated. But that what these my bugs are thinking. These bugs have known us enough. Have we understood them enough? These bugs know us inside out. Have we understood them inside out? If we would have, then we would have been all saved from these infectious disease, including COVID. But we have not, because we have no capacity to understand their intricacies and their fine network that they do, though being invisible and so simple. They live in this single vacuole and they bring down the mankind with typhoid fever. Now it is a very deadly disease. If you look into this mouse, which is a liver, which is infected, again, this is a bacteria, the rod-shaped bacteria. They're living in this vacuole, infecting the entire mouse, and the mouse dies within 8 days. That much is the power of the tiny invisible creatures. Now, if that much of the power science has, suppose as a nuclei, you can do anything that you would like to do, just like what the bacteria are doing. So what happens when you perturb the life of the bacteria? Now they are in the single bacteria in one vacuole, but if you somehow try to understand which we did in the lab, that they are ending in a single and they are very important for the life, but now perturb the system, we make them come all under one vacuole. So see here, so many salmonella all in this one big vacuole. The point is that the moment you disturb their home, their number comes down. So this multiple bacteria or many salmonella in a given vacuole, they are not able to sustain. They just die off. Again, showing that how important it is to get yourself rooted and get yourself into the place where you know that you can do the best. And this is the very important lesson that we learn from bacteria. And it is only that lesson that kept us going until I really met Jagdish over a meeting, and these two labs of Laboratory of the Hypersonic Shockwave Research and Molecular Pathogenesis Lab came together to understand that how can we break this sturdy communication between bacteria, because bacteria have a mind of their own and they do their things and they do it very, very perfectly and judiciously. As I mentioned to you that did we learn about the bacteria enough as they learned about us? Actually, the answer is no. So we took this journey and we took this challenge. And if you see here now, Jagdish with his amazing skill of hypersonic shock wave and making these hypersonic shock tubes, came up with an idea that there has to be a very tunable hypersonic, tunable shock wave application in biomedical field. And this is indeed very successful. Sometime, if time permits, we will introduce you to the children and you can actually come and visit both the lab. Now, if you see here, this is nothing but a lung section, which is a plain lung. So this is a scanning electron microscopy of a lung with this villi, etc., the cells. When the bacteria colonize, you see the bacteria made a wonderful home. This is known as a biofilm. This home is just impossible to crack. Nothing can break this home, not even antibiotic. But if you give them a shock wave, look what happens. They slowly start to disintegrate. And when you, along with that, when you give the antibiotic now, then the lung become clear. Now this shock wave disrupted their home, and the antibiotic then acted on this individual single bacteria which was floating around and made the lung very much clear, which alone antibiotic could never do it. So again saying that what science can bring by really a small dialogue across a table or across the meeting. So I would just like to tell you that there are so many ways to get into these institute. And I mentioned that 80% of the students came through this jam, and there are many, many other ways. And I am sure that I am going to see these precious children sometime in our institute, even to do a summer project. And these are my own lab and my own nation builders who are elsewhere now as a faculty, and they are making their own groups. So they are contributing them in their own way. I would like to indeed thank all of you and for giving me this opportunity. So thank you very much. Thank you, Swami Bodhamayananda ji, and thank you, Professor Jagdish, for giving me this opportunity. Thank you for listening. Thanks.
Thank you. Thank you so much, Deepshika. It was really wonderful that we could learn so much from bacteria life and also contribute to nation building. And we have amidst us today Professor Gopal Krishnan from the Department of Aerospace Engineering, who does something very unusual. Without experiments, by just using very clean and very sleek mathematics, they are able to predict whether a structure would actually fail. And he is one of the very few scientists in the world today who has developed a whole body of mathematical formulations followed by analysis, which is used in a new technology called structural health monitoring. He, in fact, has invented a new method, what is popularly referred as spectral finite element modeling. And today, without doing experiments, by just looking at the structure, doing certain experiments, doing some measurements, you can actually tell whether the wing of an aircraft is healthy, whether it is safe, whether it is something which you can use for the subsequent flight. And we are very happy to have him here. Not only he is very fond of interacting with children, he participates with us in propagation of science in rural area. He is also a world-renowned scientist in the area of aerospace engineering and fellow of both engineering as well as other academies. Professor Gopal Krishnan, thank you very much for agreeing to be with us. May I now request you to address the gathering. Professor Gopal Krishnan, please.
Okay. Thank you, Jagdish. My colleagues have already brought out very importance of children as such in nation building. I don't have a presentation per se, but I have my views written out. So I'm going to say there are two ways that I want to bring it. First, what is the science means to the nation building for any country. And I want to talk a little bit about the India story and my own experience of what is happening. So generally, when I say that, I'll say a word that country's stature in the world is measured by its economy and its military strength. And both these are linked to science and technology and the science and technology policy of the country. Hence, science, technology, development are all interrelated and they go hand in hand. So development is required in every aspect. You individual as a children who are nation builders for the entire nation, and all aspects of development happens because science and technology has to go hand in hand. Basically, science is known as a study of knowledge which is made into a system and depends on analyzing the facts, fundamentals. Basically, you need basic physics, chemistry, maths to do that. And the technology is essentially the application of this scientific knowledge. For any successful economy, particularly in today's quest for knowledge-based on economies, knowledge-based economies, science and technology, engineering, sciences are basic requisites. If nations do not implement science and technology, then the chances of getting themselves developed becomes very minimal. And this could even be rated as an undeveloped nation. Science and technology is associated in all means with modernity, and it is an essential tool for rapid development. When I say modernization, modernization has to be in every aspect of life. And it is the greatest example of implementation of science and technology. With the introduction of now modern gadgets in every walk of life, has become made that life very simple. And this is possible only because implementing science and technology together. Without having modern equipment in all sectors, be it in medicines, especially in the time of pandemic now, infrastructure, aviation, electricity, information technology. You name now all of this as modern and as advanced. And these advancement is possible only because of science and technology today. So if a nation has to prosper, they have to follow the rules of science and technology. That is very, very important, very much important. For every nation to be developed, we start from the basics, the villages. The villages has to move on to towns, towns to cities, cities to metros. These horizontal expansion takes place, and this possible of expansion is only because of science and technology. These are very much needed here. So today countries are classified into developing and developed countries and developing countries. This classification comes only because of science and technology. So basically, if you take up some of the countries that has invested heavily in science have advanced rapidly. For example, you take USA, Europe, Japan, India, China. They have, where they were a decade, 30, 40 years back, and where they are now, they have advanced rapidly only because of science and technology. So it is estimated by the World Bank that 7 of the 10 largest economy in the world by 2020 would be in Asia. And some of the examples are China, Japan, India, Thailand, China, Indonesia, South Korea. These are few things. A few decades ago, these countries were known to have very poor policies, low discipline, and no advancement. And with the introduction of science and technology, they have made ripples across the globe. The role of science and technology has played a very important part in improving the life conditions. What Deepshika said about happiness, the happiness has increased. And so science and technology has made life a lot easier, a lot better. With the advancement, for example, in medicines and analysis of diseases. And today we could make rapidly the vaccines, which normally take 8 to 10 years to come up with a vaccine. Today we have made it within a year. Why? It is because of science and technology. So apart from the medical side, there has been remarkable improvement in science, in the development of education. Today we have, in the era of pandemic, we are able to attend schools online. Because of the rapid advances made in education, communication, agriculture, industry. And the global output has increased about 17 folds in 20th century. So in spite of these advances, almost all sectors, still world is not free from hunger, disease, pollution, illiteracy, poverty. So the gap between the rich and poor has become widened very large. So by 21st century, with right applications of the research and development, nation builders like you, taking a lot of people in science and technology, we could actually thrash out all these problems. It goes without saying that the nation development and prosperity is judged large extent by the status of science and technology of the nation. So scientifically unsophisticated society means an underdeveloped nation in all sectors. It is easily understood a country which invested more on science and technology, like countries like Japan and USA, they are actually in the highest stratum of development. Whereas you take a country like Nepal, who invest very little in science, they don't have even a college of engineering of themselves. They send people to India for getting higher education. So without proper implementation of the science and technology, no nation can grow. All those nations that are labeled as low in growth have proved that where they stand today. And all that has happened only because science and technology policies. So we as citizens, especially you as a youth, who hold equal responsibility for nation to grow with all possible facilities for the research, and then you have to take the research, motivate and attain what is required for the nation. Take up science. Science is the engine for growth. And that is the fundamental for all the countries. So now let us talk about India's story. So India is in a unique position because it is the world's largest democracy, and it is most diverse, with so many languages, so many cultures, so many food, so many things, yet we have made rapid strides. And it has emerged as a major economic power in spite of all its problems, especially poor infrastructure. A key element to this growth story has been the base of science and technology that India has created in a planned manner, And once this was done, the country took to about 7 to 8% growth rates until, of course, the pandemic came. All countries, the growth rate has come down, and India and China are the only one which are looking upwards, mainly because we have a solid base in science and technology. Let's understand a little bit about this. We have to look at the past. In the post-1947, we got our independence. In the post-1947, we were a very ancient civilization, and it had a large history in the fields of mathematics, logics, astronomy, medicine, and many other areas. And basically, and once it was growing, then it was interpreted in between because of invasions, and then the British came into it, and there was a lot of fighting in between going on. But British, in some sense, has restored some kind of political unity in the country. And the country, because of all these problems, missed the Industrial Revolution. And because of that, it could not progress rapidly. But however, with the advent of British and their encouraging our citizens to study English, mathematics, and science, and with the help of reformers like Swami Vivekananda and many others, we were able to actually accept the education, the deep background in science, mathematics, and technology. And if you look at our own spectrum of scientists, we had only 2 homegrown Nobel laureates in the pre-independence days. In the British rules, basically Rabindranath Tagore for literature and Sir C.V. Raman in physics. But notwithstanding, we had some very outstanding scientists, somebody like J.C. Bose, very famous for wireless and plant physiology. And we always had the mathematical genius of Ramanujan, who was at Cambridge University, who contributed immensely to the growth of science and technology in the country. However, after independence, we have to make our own policies for science and technology. And we had a very right man who was heading the country, that is the Cambridge-trained Prime Minister Nehru. And he made science as the cornerstone for his economic development. You should look at what was India at that time. The country was lacking in the basic essentials such as food grains, milk, communication facility, education facility, and so on. It was unable to produce anything by itself. Whether it is steel or heavy power equipment, there was hardly any banking system outside the big city. That is when he made very bold decisions. What are the decisions he made? He established CSIR system. CSIR system was the cornerstone for our science and technology development in the country. He set up 5 major IITs, and IISc at that time was making a name for itself, even though it was established in 1900s. So over the years, with all the educated population and practicing some soft socialism, India rose itself as a self-reliant economy. And the application of science and technology through numerous research laboratories and spread of higher education was the cornerstone for our science base in the country. And the many steel plants and power generation equipment were set up, and it made country self-sufficient in less than 50 years, which is really outstanding because this is a policy. It's a policy that the government took. The nationalized banking system, so they nationalized most of the banks, which was able to possible to reach every village and escape the global meltdown. So in 2008, there was a global meltdown, major recession in all the country. India was not affected. Nuclear and space industry, we made rapid advances, and our advances in the space is very well known. You all know our moon missions, Mars missions, these are all completely indigenous efforts. We didn't depend on anybody to have it developed. And so then the liberalization policy stated when we were stuck with the foreign exchange, and this was revolutionized by a telecom revolution. We went from 2G to 3G, now 4G, we are now getting into 5G. So now with the availability of 5G, you know what the things can happen, how the country can bloom. This was followed by the IT-enabled activities in many sectors. And the IT revolution that took place the success is known world over. Yes, in some sense, India is at crossroads and bold decisions are required in future to make ourselves from a developing nations to the developed nations. It has a demographic dividend with half of the population of 20 to 38. That is you people. And that is the greatest advantage. People say population is a disadvantage. No, we have the advantage of very young people who have inculcated science as the basic thing in their education. And this is the greatest advantage India has over other nations. And you people like you are going to contribute to that in a big way. Country has taken very new initiative in investing in young human capital to develop skilled workforce. The new national education policy is towards this direction. The new policy has come and the government has implemented it. This is going to take the science and technology base in the country, in the youth, to the next level. And infrastructure has been a top priority. Today, you see our roads are a lot better than what it was before. The power sector has improved dramatically. Every village in the country is now electrified, and the IT sector has penetrated in all walks of life. And so this is all because of some of the bold decisions that the country has taken. Water and health sector similarly has improved rapidly, and now water is going to be the next important thing where you could see many wars, and that technology has also come into a big way. Let us look at what has happened in the current setup. In the current setup, the current government has adopted self-reliance as the cornerstone of their policy. You would have heard about many of the slogans like Make in India, Atmanirbhar Bharat, as reverberating across the countries. It is talking about self-reliance in all the field so that we don't have to depend. And this is very, very true because of the changing global economy where many people, many countries have becoming protectionist. They want to only do what is the country. They're not looking at the global scenario and what is happening to China. India is very well placed to fill in the gap because it has young and scientifically inclined youth to accelerate its growth by investing heavy now on manufacturing, banking, and health sector. So already several car manufacturing companies have moved from China to India. Now India is welcoming all of them, and there more will come. And India has become a vaccine hub. The world looks for India in the pharma sector that is expanding rapidly. And now there is a major smart city program. Many small towns are going to become cities are going to become metros, and all of this rapidly changing world that you will see in the coming decade. I'm not even talking about 20 years. And our successes in space science is very well known. And India is fast emerging as a startups. And as many startups are coming, many new ideas are coming. For example, in our own lab, you could see people like Jagdish have taken shockwaves. Sometime back, we never knew shockwaves can do so many things. Now, Jagdish, along with Deepshika and others, are coming up with something like a drug delivery, a needleless drug delivery. And India is also a diabetic hub. Now they have got a diabetic wound healing facility. We never thought the innovation like Shockwave can take it to that level. Because before I came here, I didn't know all of this was possible with shockwaves. So all these developments are possible only because India is committed to science, and the country's prestige has leapfrogged in recent years. Our voice is heard all over the world on many affairs. And India is invited to G7 developing countries in the next meeting. And we are slowly inching towards becoming the permanent representative in the United Nations Security Council.
Gopi, we can.
Yeah. So, in short, I am saying that these are aspects that are required for nation building. And Dr. Kalam wanted India to be a developed nation by 2020, but we are almost there. Pandemic and other events have hampered this growth, and we are inching towards that. So I end here saying that we have a very good, our children are the nation builders who are inculcated deep into science, and our country has very bright future. And this is actually the goal that Swami Vivekananda wanted to happen. Thank you very much.
Thank you, Gopal. It was very nice that you took us through a journey of where India was during independence and then where is it today, and what bright future it actually holds for the youngsters. Friends, I am also very glad that we have Professor Satyam Suhas, who is the chair of the Department of Materials Engineering in Indian Institute of Science, with us today. Professor Suhas does something completely different to what you would have heard, starting from the shirt and the dress that you wear, to the mobile phone, to the household utensil. Everything is material. If we did not have good materials, then there is no way that we will be in a position to have a decent or ease of living. So he comes from the materials research viewpoint, where he does some fundamental work to understand the texture of material. He looks at the crystal orientation of different materials, and then he is one of the world-renowned specialists in the area of texture. And he is from IIT Kanpur, and then he has been with us for the last almost close to 20 years. And we share a lot of common ideals about India, the rural technology, and the way the character and science has to go hand in hand. And welcome, Professor Satyam, to this event. And over to you, sir. Professor Satyam Suhas from Department of Materials Engineering, Indian Institute of Science.
Thank you, Professor Jagdish. It's very nice to be a part of this event. First of all, I would like to pay my deepest regards to our Swami Vivekananda ji, and then also to Swami Bodhmayananda ji for inviting me for this function on your suggestion. So today what I'm going to talk is generally about spirit of science, because I did not prepare any slides, so I will just talk about the spirit of science. And I will be brief because I know I'm the last speaker. So actually, the spirit of science is imbibed in mankind ever since the evolution of mankind. So it has gone hand to hand with evolution, may it be the discovery of fire, discovery of wheels, and all that. Human being needed something and he did something. He learned from the nature. That is what is science. He learned from the nature. A wood log was rolling and he learned that, okay, this can be a faster way of transport things, and that therefore it is his inner knowledge. Basically, the knowledge was within human being itself. He just tried to observe it and applied his sense, his mind, and then it transformed into some scientific discoveries. So this is what it goes on. And basically there was always a quest to know the nature. And in Indian context, I would like to mention that in our country, science has developed with a social fabric, because today's topic is science and society. So I would say it has developed a social fabric. Ancient times, if we consider our ancient scientists who developed, who did marvelous things, starting, some of them were mentioned today by various speakers, like a discovery of zero, or any knowledge about astronomy, or about the surgery, medicine. All these things were developed. And who were these people? These people were primarily ascetic and spiritual people. So their minds were very pure. They were not so much entangled into things which were distractive to them. And then they looked with their pure inner instinct, tried to see when resources, when tools were not there, they could measure the distance of Earth, they could see all the constellations, they could define the distances, they could define zero, they could define the different kinds of geometries, all these things. And then, of course, then they applied it to the service of mankind, learning from nature. They developed the treatment methodologies, they developed surgery and all that. It was basically evolutionary thing, learning from nature, and also something which is well within ourselves. In spiritual world, we all say that everything, the entire spirit, entire Brahma, what we call, is inside ourselves. So just we see the mirror of what the supernatural power is there, and we apply it, we learn it, and we try to imbibe the whole thing, right? There are actually, according to me, there are two spirits that drive science. The first is, the most important one is self-satisfaction, what we call in Sanskrit, Swanta Sukhaya. So most of the great science has come because of the self-satisfaction. And whatever we have seen, that if we consider the life of scientists, not only in India, all over the world, people who did it for their own pleasure or own satisfaction, they were in the top of this scientific pyramid. They really made some very great contributions. Later on, there is another group of scientists who have come, who tried to help society, right? So who were seeing that people are suffering, and then they tried to do something. They learned, they were intelligent minds, they learned something from the nature, they learned something from the system, they learned something from the society, and then they tried to imply this to help people. So there is a very beautiful shloka in Sanskrit where a scholar says that na tuham kamaye rajyam na soksham na punarbhavam kamayed dukhtaptanam pranina martinashanam. I don't want the kingdom, I don't want fame, I don't want anything, even liberation. What I want is the people who are suffering, who are needy people, I should be able to take away their sorrow and make them happy. I think this was the basic spirit of basic scientific spirit with which India has grown. And I'm more and more convinced that this was actually Swami Vivekananda's spirit. He saw Indians suffering with poverty, with all kinds of oppression. He wanted that the country should come forward and stand on its own feet. It has a glorious past, it has a glorious history. And then, so that is how you can imagine in late 19th century, when people were not thinking, in India, nobody was even thinking or even optimistic about freedom. Swamiji thought of an institution of higher education. And he just, and that was the inspiration which he gave to Sir J.N. Tata, and because of which our Indian Institute of Science was founded. He told that we should have an Institute of Higher Learning. There was another important person to whom I really give a lot of credit in scientific endeavors, and I have a lot of regard for him, is Pandit Madan Mohan Malviya, who founded Banaras Hindu University. And he went into this concept that we should have ancient Indian science and Western science on the same campus, and we should learn together, learn from the West, and then finally, we also have to build up upon our own things. This is very important. According to me, this is very important. We have to know what was developing here, what has developed here, because that gives us confidence. Otherwise, for any important thing, we always look towards what West has done. That is, there is nothing wrong in learning from anybody who has the knowledge. That is the true scientific spirit. But at the same time, we must also have confidence that we can do it. So that was a very nice spirit in which these science, the two kinds of streams of thought processes come together, and then they develop, they provide a very sound scientific foundation to our educated, our youth or our society. Basically, all the learners are youth, so all these efforts or all these experiments were aimed at youth of India. So to do that. Now, there is another thing that I would like to bring, that science has progressed from there. Science has also shown some kind of a different phase when the human beings were in conflict in the early 20th century. 2 world wars came. And then there also science has contributed a lot in terms of its own development, sometimes in resolving the dispute, sometimes it has created, like what I would say, that science was like Shiva, that where it was really created, what Professor Jagdish in his initiating speech, he has told that. So there, Shiva, the science has taken the form of Shiva, and then finally the destructive weapons were made, but probably for a better good of mankind. Had atom bomb not been discovered, probably the Holocaust of Second World War wouldn't have stopped so easily. So science has played a different role over there. So science is always needed. Now coming back to what we need in India at present, whatever way we have come forward, we have to do, according to me, we have to do 2-3 things. One is we have to build up upon our own knowledge base in science, and with a complete pure spirit, not to show that we were the great, right? Because the moment we have this ahamkar that we were the great, all your purity of learning goes away. The learning can be done only when our aham is not there, our aham is grounded. So we have to have confidence that we can do this. So we have to have, with the purest spirit, we have to develop whatever on our ancient knowledge. We have to imbibe the best what is needed from the West and accept it and transform to our basic needs, what Professor Gopal Krishnan has just said, that there are important things like the most important is poverty eradication, self-reliance, environment protection, and basically to bring happiness in mankind, happiness in true sense. So this is very important thing at this moment, and I am pretty sure that the youth will play a most important role. I can share it, the youth has, over a period of time, youth has refined. They have become more confident. Today's students are more confident and more thoughtful than the students of our generation, because now they have at least a platform to think about. They have various knowledges available to them, and I am quite hopeful that with this generation, we will see a leap in the progress, a leap in the development of our country. With this, I close my
Thank you, Professor Satyam. I think it was a very diverse and different views being discussed in a very short time. But in a nutshell, if you really want to say what every speaker told here, science is something about being with the nature, asking the question why and going behind finding answers to that. So in a nutshell, I think for nation building and science, first of all, we should take care of our body, because a healthy body will lead to a healthy mind, and a healthy mind and healthy body at individual level will be able to think of greater things. And at the same time, we should have more than our laptops, we should have our think tops. Think top is your brain. And science actually teaches you to use your brain, ask the question why. And there can be no greater science than your surrounding. For example, there is fantastic chemistry in your kitchen. Your mother is the greatest scientist you can ever have. The kind of spices that she uses, the kind of passion and love with which she cooks food, and so many proteins, everything is there. It's a nutritious food. So there is a lot of chemistry in your kitchen. There is a lot of biology in your bathrooms. So maybe you should be aware how to clean, keep our surroundings clean. And then there is a lot of physics in your playgrounds where you look at kicking the ball, how Newton's law works and things like that. So nation is not something which is superficial, which is not just a geography of people, but then it is connection between minds. So it is in this context, I think it is very important for us to become good citizens. You can become good citizens provided you take care of your body, sleep well, eat well, think well, and laugh as far as possible, remove negativity, and condition your mind to concentrate on a given task. And if you take any one day in any of the scientist's life, the greatest treasure for us is we keep on asking questions, and we are students for our entire lifetime. All of you are in college, you would remember and you would agree with me, student life is the best life. But if you want to be a student throughout your life, then you can take up science. As Swami Paramahamsa always used to say, as long as I live, so long do I learn. So if you want to be a positive contributor to nation building, you should never think education is over with few examination, plus 12 or a degree. It's a continuous learning process. So maybe with these kind of thought process that you have heard from several speakers, I would now throw the forum open, and anybody who would like to ask a question, you are welcome. And Swamiji, it's over to you.
Yeah, I'm amazed at the diversity and the unity of this entire webinar. For the first time, I'm listening, exposed to the cream of the Indian Institute of Science, though I appreciate, admire, and quote a lot about it. But going into the depth of every, from Professor Arunan to Professor Satyam Suvas and yourself, one of our volunteers is a research scholar entering into PhD in the Hyderabad University. She visited IASC recently in Kapala before the pandemic. Sri Charita will give her observation, and then if she has something more to ask the scientist, I request her to start the ball rolling. Sri Charita, please unmute yourself and you can speak.
Yes, Swamiji. My humble pranams to the Holy Trio, namaskars to Swamiji, and namaste to all the greatest scientists of our country, of the world. In fact, it is my proud opportunity that Swamiji has given us, that in this platform, on this day, Swamiji, our source of inspiration, and seeing the great scientists, as Swamiji already introduced, I have just joined my PhD in Hyderabad Central University, and there was always a doubt in my mind. I mean, we learn a lot in Vivekananda Institute of Human Excellence, Swamiji's message and all. So I really had, how do I implement those in my lab and all. So as soon as I heard the diverse experiences, the diverse insights of the scientists, it has really inspired me. And at a personal level, it reminded me, or rather I should say, it made me realize the responsibility as a researcher I carry, that I should carry throughout my career, or throughout my life from now on. So I'm really thankful for this opportunity, and really thankful to all the professors who had shared their insights. And also, as I belong to the life sciences background, so I could really connect well with Deepshika ma'am. So I was really fascinated. So when I used to study in my post graduation days, I used to literally get fascinated by comparing science with the very general things around. So when ma'am was talking about vacuole, the salmonella, I was really amazed, and it is very fascinating, and it gave me insights as to usually it is a general talk outside that, once you get into PhD, it is very straining, and many of my friends, they keep asking me, you are now next 5 years is full straining for you, it is a strenuous job and all this. But now, after hearing the scientists, I feel how lively and how cheerful all of the professors are, and it made me even more inspired, and it made my ground more strong. Thank you very much, Swamiji.
So thank you, Charita, for your observations and feelings, and your responsibility towards the research and towards society also will get enhanced, will increase, and you will have the support of Professor Jagdish and others. So I'm sure youngsters should be guided and molded for the welfare of the nation and for your own search for truth. Jignasa, if it is there, it's all joyful. In fact, as you said, I'm also amazed and inspired to meditate more and to think more and to apply these teachings more in life after listening to all these 5 professors of the topmost institute in the country, in the world. We are proud of it. If anybody wants to ask questions, can raise your hands. We'll take 2 or 3 questions only due to paucity of time. And you can raise your hand. Our volunteer will unmute you and you can speak. Ask your question. Then it will be clear for us to understand what exactly is in your mind. Or we'll take some observations.
Swamiji, can I take just a liberty to answer one question which is there in the chat box?
Yeah, please.
Pranam Swamiji. So first of all, just a small way, Shri Charita, you are indeed a student of Vivekananda Center, because the way you took a lesson from life in a vacuole, I was amazed. Yes, your life is in a vacuole during PhD, but you know that you will be extremely comfortable and successful, and nobody can disturb that. Anyway, now coming to Shri Rekha's question. Do you use shockwave on the bacterial cell? Can you please tell, ma'am? It's very interesting and novel. Yes, Shri Rekha. Actually, these shock waves are used to disrupt the colony or the microcolony that the bacteria make, because it's very sturdy. No amount of antibiotic can penetrate and kill them. And this is a serious kind of an hazard to all these medical devices that is implanted in the body, be it stent, be it catheter, be it any kind of the device. So bacterial, we call it as a biofilm. So it's very sturdy, and it is a big cost to the medical fraternity to in fact keep on changing the stent or keep on changing the implants, etc. So the shock wave in our experiment, it could very clearly kind of break the home or break the biofilm, and then the bacteria became susceptible to the antibiotic, and we could clear it off in an animal model. So yes, they do many things to the bacteria, but first most important thing is they can break the sturdy biofilm. Thank you, Shri Rekha, for the question.
Yeah, Pranav Atreya, what's your question or observation, please? Pranav Atreya, introduce yourself. Yeah.
I am Pranav, studying in 8th class.
Yeah, what's your question? Or
Sir, I want to be an astronaut. How can I be?
You want to be an astronomer, you said, or astronaut?
Astronaut, sir. Astronaut.
Okay. So currently there is no structured training program that is available in India. But one of the basic qualifications that you would need is to get a degree in science. And then, of course, in United States, there are structured programs where one could go through these training programs because they have several space programs where astronauts are routinely sent. India's Gaganyaan program is just beginning. So it may not be too long where you will also have institutes which actually offer the training, provided we have people going into space in a repeated manner. So right now, the route one could take is do a good degree, and then you also need to have good, of course, physics, and then some interest in flying. And some of the people who are in the Air Force have also gone on to become astronauts later because they can experience these microgravity conditions in a better fashion. So I would leave it at that. Maybe you can get in touch in case you need more details.
Thank you, sir.
Please, after asking the question, please mute yourself. Ram Mohan ji, next question or observation from Ram Mohan.
Yes, sir. Namaste. Salutations to Swamiji and the scientific community from the Indian Institute of Science. I have two concerns and questions, sir. One is the scientific inventions made by the various scientists across the world. Are they being hijacked by the market players? I mean, in making the cost a bit unaffordable of the invention, the fruits of the invention. That is one thing, sir. The second one, there are various branches of science, approximately in my estimate around 20 to 25 or even more branches of science. Do we have a system where a integrated forum is available so that the application of one branch of science into the other without the wastage of time and energy, or without a reinventing already an invented process, that foolproof system, whether it is in place? These are my two questions out of concern. Thank you. Namaste.
Yeah. Sir Satyam, you would like to answer that?
Yeah, so I would like to answer your first thing is where the lot of scientific discoveries, if I understood it correctly, where all the scientific discoveries are made by scientists and market forces are taking it up. So this, I would say that this is a kind of integration of science to society. Society consists of all forms, and out of which there are people who are also important component, the people who basically make wealth out of it. So as long as it is used for a good purpose, I think there is no harm in market forces taking it up, because some way it has to go to the people, and scientists by themselves, they do not have any means to take it forward to the mankind. This question was in fact very, I will just be a little informal here. When our Prime Minister visited Indian Institute of Science, and he asked the same question, that you people have done so many discoveries and so many good scientific advancements, why it is not being directly applied to the mankind or society? So one of us has very vividly answered it, that we are ready to share it, but somebody should take it up and transmit to the society, because we cannot go with our inventions because we do something and next day we do something else, or we try to do some better things over whatever we have done on the previous day. So that is, somebody is required to transmit this. Now in that process, whether you call it multinational or any social organization, somebody has to take it up. And in society, the driving force is, of course, money. Many a times this becomes inevitable. But of course, if there are some forums, there are also some forums which take scientific discoveries, social organization, and try to take it to society with minimal investment or minimal cost for betterment of downtrodden. That is also most welcome, and it should be encouraged. Now, your second question is whether there is a common forum for all the scientific areas, or there are many branches of science. So there has been a recent trend which is called interdisciplinary nature of science. So there, not all the branches of science, but many branches of science together form interdisciplinary centers. At least in our Indian Institute of Science, we have many such interdisciplinary centers where, like, for example, myself and Professor Jagdish are part of Energy Research Center for Interdisciplinary Center. So there people from aerospace, materials, physics, chemistry, mechanical engineering, we all come together and work on a common problem which requires all kinds of expertise. Similarly, there is a bioengineering center here in ISC where people from engineering sciences and biology, they come together and do something which is needed. So there are some interdisciplinary initiatives, and I think there are more and more coming up in the next few years. So I hope it answers your question, both the questions.
Ramohanti, just to add, today there is no invention or a product which can be done by only one branch of science. The disciplines have disappeared between various branches. All of us have to come together. In the beginning, you are right, some invention, some market people will pick up and make it very costly. Simplest example is when mobile phones came into the market, they were very expensive. But over a period of time, easily the cost is going to come down and eventually it will become affordable. And today in market terms, your invention value is 20%, 80% is packaging, which involves properly packaging that, finance people, business plan. So all of that have to come together. So it's inevitable that everybody works together to make life better and bring out a product. We can move on to the next one. Yes.
Yeah. Any other observations that our participants or our faculty members would like to make are welcome before we end our webinar, this excellent webinar for this day.
There is a question by Shai Charanath.
Yeah, please.
On shockwave application in biomedical. Maybe Deepsika or Jagadish could talk about it. It's in the chat box.
Okay.
Yeah. Jagdish, you would like to take this question? Then I will take two other questions which are there.
Okay. Fine. Shockwaves are being used for several applications in biology today. And one of the most common application which you see is kidney stone removal using extracorporeal lithotripsy, where kidney stones are removed without surgery. This is already being used by all the people. More than 85% of kidney stone today are treated using shock waves. And in recent time, we are looking at using shock waves for healing the wound without any medicine. That is something which we are developing in collaboration with Professor Deepshika. We have also developed shockwave based needleless drug delivery. Without needle, you can inject drug inside, especially for vaccine delivery. This would be very useful. We have also got some very interesting application on using shock waves for removing biofilm, both in dental. Dental biofilm is also something which we are doing. And weak exposure of shock wave can actually provide very good immunity. So this is something which might become a part of treatment process. Nowadays, you would have observed when you have infection, one round of antibiotic doesn't cure you. But you walk into a chamber, walk into a clinician or a doctor, and you have a chamber where you are exposed to these waves, you will be in a position to essentially get some immunity plus get cured, and the antibiotics will start acting faster. So there are several applications like that, including you can even put a DNA inside. People are looking at using shock waves for cancer treatment and several things like that. Yeah. Yes, Deepshika.
Thank you, Jagdish. There is a question by Yashwant. Thank you, Yashwant, for asking this question, which is actually very important, saying that whether the shock wave disrupt the colony, but won't it affect other cells? In a bacterial colony, if the bacteria is of a single nature, that means it is made up of a single species, the entire colony in fact get disrupted. It's a very important question because we are looking into something known as a polymicrobial. So as Jagdish mentioned, in the dental biofilms, it is a polymicrobial colony, which is made up of more than 8 to 10 different microbes. So in that case also, yes, it breaks very beautifully. And I think why you asked this question is, won't it affect other cells? I think you meant human cells. Say, for example, if I am thinking of giving a shock to disrupt a biofilm associated disease, which is very important for me to now save my devices, will the neighboring cells, like other epithelial cells or other organ, will it get disrupted? Actually, the answer is both yes and no. Yes, if we little bit make a mistake in gauging our pressure, and absolutely no, because the system is very foolproof, that it is only that much pressure and it does not give rise to any kind of harmful effect on any cell type. Can it be applied to cancer cells? The answer is yes. There are certain studies that is going on, as Jagdish mentioned, and we are in fact going to study the role of shock waves in glioma and tumor induced in the mouse model. So we are going to do that. Now there is a second question by Grishma, who mentioned that I am an MBBS student and how can I participate in ISC as a volunteer? Grishma, you are very much welcome to work in our group, because one of my first graduate student, he was MBBS doctor. He did not want to go to MD and he listened to his heart and came and started Sandeep Ishwarappa. It is Sandeep who in fact bridged myself and Jagdish and carried forward this needleless vaccine delivery system along with Dr. Rakesh. So you are more than welcome, Grishma, to visit our lab and maybe work for some summers. Yeah, thank you so much.
Thank you very much. Surendraji will take the last point. You want to say something or ask question? Surender Veru.
Yes, yes, sir. Good evening to all, sir. This is Surender Veru. I would like to add a point which ma'am has given.
Can you be a little louder?
Hello, sir. Am I audible to all of you?
Yeah.
Sir, this is the only point need to consider, sir. Is the only science is playing vital role to become a technology, or art is also part of science? But ma'am has said, 20% of human values are considering for producing of 80% of output. There we need to also consider art is also part for developing the nation building. But ma'am told only science is helping to build the nation. So my concern is, why can't we also add art is also part of building a nation with all the activities that you are doing and also share to us.
Surendranath ji, actually it is the science I meant. It is science by definition. If you really look, it is about all learning. So whether it is arts or whether it is music or whether it is painting, all comes under that umbrella of understanding and exploring the truth. Absolutely. So it is very well an integral part of the so-called understanding of the science. You cannot dissociate. The physicists are the strongest musicians. The tabla players, the violin players, the veena, the entire raga, the Michaelis-Mentel's equation, biochemistry, the major equation was converted into music. So there is absolutely no demarcation. So indeed, it is very much a part of science and in nation building.
Thank you for that.
Thank you.
Yeah. So we come to the end of this brilliant, innovative, and really fantastic session, which has created a big stimulus, a kind of inner drive for all our youngsters and their parents or their faculty, whoever has attended this session, both in YouTube and in the Zoom. And I can only say namaste to everybody. Thanks to the entire team, Jagdish and his colleagues, and personally to everybody, to Deepshika Chakrabarti, to Jagdish once again, and Satyam Suvas, our E. Arunan, Gopalakrishnan, amazing people you are. And this idea of seva to the nation, Chaitanya Devaki Seva Karo, through science, as you said, somebody through sport, somebody is doing through meditation, somebody is doing through culture, through upbringing. So, but you have taken up a very high, this one, your wonderful presentations, joy, the insights that you have given, I think, are thought-provoking. It is worth slowly, should I say, I have to internalize them. Our students have to internalize them. And this scientific approach, which Swamiji wanted, which he himself was Though he did not go into physical science or medical science, but then the spiritual science question, have you seen God? Or that one question which Sri Ramakrishna asked his brother, can you teach me that one thing by knowing which everything else I will know? What an amazing question, or a scientific question a 16-year-old Gadadhar is asking his elder brother. I want to know only one thing I don't know. I don't want to learn 500 things, by which I'll get connected with everything. Brother said, he got confused. And then Sri Ramakrishna said, if you're not able to do that, I will find it out by myself. So that is how his search for truth, his search for higher consciousness, his search for unity in this cosmos was phenomenal, is worth noting. And then that message, how it went through Swami Vivekananda and the great scientists. As you were speaking, I was recollecting how Meghnad Saha, Satyendranath Bose and J.C. Bose, with limited resources and without support from the government, things like that, how much they worked, how much they sacrificed, whether it is in astrophysics, whether it's in quantum physics, that inspired me a lot to understand more. I've been reading all that, great biographies of great scientists. And in the modern times, technology used by E. Sridharan or Amul company, Korean Varghese Ji, and so many wonderful people who are working in DRDO or DRDL or NAL here and there. So this is a wonderful occasion, great tribute that we have offered to Swamiji on his 150th birthday. And we wish you would occasionally accept our invitation, Jagadish Ji and his colleagues, and inspire our youngsters in periods of time in 2021. And we would like to participate, visit IISc, the place of the temple of learning, the temple of research, and become more inspired for service of the nation. So we conclude. Jagadish Ji, thank you very much once again.
Pranam.
Yes. And tomorrow I am coming to Bangalore to offer my pranams to Arshananda Ji by morning flight, and hope if you are around there, we will meet.
Yes, sure. So,
yeah.
Thank you very much.
Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityorma Amrutangamaya, Om Shanti Shanti Shanti, Harihi Om Tat Sat, Sri Ramakrishna Arpanamastu. Offering to Swamiji our tribute, we conclude this function and wish you all good night, Shubhratri, and happy Sankranti greetings from VIH. Thank you. Namaste. Namaste to all.
Namaste.